So today we are pretty excited to tell you about a couple of upcoming features that we are planning for the next testnet release. And we have a few team members that are here with us today. So Talal will talk a little bit about a validator setup and some things you should look out for as you're preparing. Then Gus will tell you a little bit about how we're going to start tracking validator performance on the upcoming testnet, and then Jackie will tell you how to use various queries on the Axelar core and what important log information you should be on the lookout in the upcoming release. I think as we announced a few days ago, the plan is that the current testnet is going to be powered off on Thursday, and the team will take a few days to prepare for a new iteration of the testnet. So with that, let me share just a few slides to quickly run over it, and then I'll pass it to the rest of the team. All right, so just to kind of a step back for those of you that are, first ones to listen to this presentation or get involved with Axelar, what are we really trying to do in the long term, right? Our goal in the company was started with a premise to allow users to use any asset they have in any application, any platform, right? It seems like a very simple goal to ask for, but the technology and the stack that's required to build this to actually make this happen is pretty complicated. And that's what we're all doing here. And you guys included that are helping us run the testnets and set up validators. So on a high level, you can think of Axelar as an overlay network across different blockchain ecosystems that would allow us to route assets, and information and deliver it from one chain to another, right? So the end goal, if you think of it, if you are a builder of an application, you can interact with Axelar gateways to route your information and assets from one platform to another. So that being said, as an overlay network, Axelar is connected to various blockchain ecosystems, and the validators are responsible for monitoring information that comes into these various gateways, kind of voting on it, executing a consensus in various multi-party protocols, and then delivering information to the destination chains. So the first use case that we are, of course, focusing on, that we see a lot of demand on, is just unlocking liquidity for a lot of various applications that we have in the ecosystem, right? So today, you have these applications that are built across different blockchains, and you have lots of assets that are spread all across the ecosystems. And the assets that are available to these applications are usually just the native assets that reside on the platform where the applications were built, right? And our goal is to make an interconnected fabric to make all of these assets accessible to all of the applications that have been built in the ecosystem. And so this is a first use case that we're focusing on, but there's more that we're working on in respect to general composability of these applications as well. Now, so let me just tell you very briefly what is the technical approach that we're taking in order to kind of connect all of these ecosystems. Everything really comes down to three simple phases. So one, we want to make it easy to set up connections across chains. Two, we want to make it easy to build various application level interoperability protocols. And three, we want to make it easy for the applications to interact with all of these protocols. Okay, so today we're largely going to focus on just the first step, right? Which is how do we make connections across these ecosystems, and validators play an important key role into this because you're going to be running the Axelar validators, and you're going to be responsible for managing connections to some of these external chains as well. All right. So what are the key components of a validator stack? There is a consensus. I think you're all, if you ran node on the testnet to date, there is a Tendermint consensus that we're leveraging. That's sort of what unites all of the validators and allows them to reach an agreement on decisions for the cross-chain transactions. There are various sort of finality gadgets that we have. So in particular for proof of work chains, you have to wait for a certain number of confirmations depending on the chain in order to actually finalize requests from it. And so as a part of the consensus and the validator stack, there are various kind of routines to finalize transactions. There are various multi-party crypto protocols that we have in place. So if you saw recently, we open sourced Toffen and Toffen-D libraries, and Gus, who is here on the call today, was one of the key authors behind those. And those libraries provide various cryptographic routines for threshold cryptography, as well as basic like multi-signature cryptography. And so those are needed to reach an agreement across the validators in order to perform sort of write requests on these various gateways that we're deploying across the ecosystems. So, and finally, there is this programmable layer that's built on top of the Axelar, and that layer is leveraged in order to push gateways across different ecosystems, allow validators to register on the chains that they want to vote on, perform various kind of key rotation functions, and so on and so forth. And we'll talk more about it throughout the talk today. All right, so let's take a look at how the validator actually looks like and what is the stack. So on the high level, there are three processes that you're going to run if you run in a validator. There is a basic Axelar core process, which is going to just be responsible for the Tendermint layer itself and the consensus. There's a process called val-d that's going to be responsible for broadcasting messages, you can think of it, and listening to various events on the chain. And there's going to be a process called Toffen-d, which is going to be a daemon responsible for the multi-party cryptographic protocols that I mentioned earlier, right? So multi-signatures, threshold crypto, and so on and so forth. Also, as a validator, you are going to register to vote on events from external chains. So, Bitcoin, Ethereum, Avalanche, and so on and so forth. And I think there will be a few chains that we'll want to test on the upcoming network. And as a validator, you do have an option to register for those things. So, if you don't want to register them, you don't have to. But in order for a chain to be activated, a certain threshold of the validators have to register to vote for events on that chain. Okay, so as a validator, you just set up, an RPC connection. You don't need to run, validator nodes or anything complicated for those chains. Those are like standard nodes that are usually pretty lightweight, and then you just configure your RPC endpoints from the Axelar validators to query requests from those chains. And then as the network will be rolled out later, there will be various incentives to actually incentivize you to run as many RPC endpoints as you want. And the more you register on, the more rewards you can collect along the way. And as I mentioned, kind of any request on the network then has to pass a certain threshold. Once that threshold is met, then we can vote on events from that chain. All right. So as a network, Axelar effectively responsible for, let's just simplify it, 4 core functions. Okay, there's this external gateways that I mentioned, which are effectively smart contracts that are going to be deployed across various chains. Then the Axelar network is going to manage the keys and the validator sets that are authorized to perform requests on these gateways. So if some validators leave the system, some validators join the system, there's a kind of key upgrade protocol that will have to be invoked. As a validator, you will confirm various cross-chain requests. So let's call them read operations, right? So if there is a transfer from, let's say, Bitcoin to Avalanche, then somebody needs to confirm that transfer on the Bitcoin. So that's a read request that you as a validator would execute through the RPC, kind of vote on it, and propagate it through the Axelar consensus. And finally, there is a corresponding write request that has to be executed, right? So write request is where this multi-party crypto libraries come in, where all the validators after confirming a request, execute an action that says, okay, now here's a corresponding, write transaction that has to be executed on the destination gateway. They collectively co-sign it, and then that transaction gets posted on the destination chain. Okay, so those are essentially like the core functions that you as a validator will execute. All right. Another feature that I wanted just to mention that we're rolling out into this upcoming release is what we'll call cross ecosystem routing. And so effectively the idea is the following: Axelar being a Cosmos SDK network, it can help you deliver, let's say, your assets from Cosmos-based chains to other ecosystems, right, and back. So for instance, if you are building an application like Osmosis or Anchor or any other application in the Cosmos ecosystem, you can ask Axelar to generate a specific destination address for you that will be linked to a particular destination chain, right? So if you want to transfer like Osmo to an Ethereum chain, you can just issue a request on the Axelar network and get a corresponding destination address. And then once you transfer the funds via the Cosmos native IBC protocol to this corresponding Axelar generated linked address, then the rest of the network will actually deliver your assets all the way to the destination chain that you want. So in that case, you don't have to think about, paying transaction fees. You don't have to think about your users generating like multiple wallets and so on and so forth. So we can directly route it from a Cosmos-based chain to an EVM chain, your assets and back. And as long as you link from the application, you don't need to do anything else. So that's a pretty exciting feature, and will give us kind of a many-to-many connectivity from the Cosmos-based chains to these EVM chains that we're working with in the initial implementations. All right, so I'll pause it here and pass it to the rest of the team. Just one thing to note is, you can follow us across various channels, and we are actively hiring across various roles. So, if you're interested in getting involved one way or another, take a look at the website and send us a note. So on this, I think I will pause and pass it to Talal, who is going to talk about a validator setup and some of the key things you should think about while setting up your validators for the upcoming release.
Hey everyone, good to be here. So there's two things that I primarily wanted to talk about today. The first is, as Sergey mentioned, setting up your validators in a way that they're not exposed to DDoS attacks and they're generally secure from the internet. And the second thing that I want to talk about was registering seed nodes. As far as the validators are concerned, we use the Cosmos SDK, and there's a pattern that they encourage people to use, and it's called the Sentry nodes pattern. You can think of this as, in the classical sense, if you have a load balancer in front of your core applications, and then the load balancer is the one that's exposed to the internet, and the application sits behind, and that kind of gives you the protection you need against DOS and DDoS attacks. So a similar pattern is here for running your validators. I will share some links in the Discord channel as well as on the chat here on how to get that done. But basically, what the architecture looks like is that you have your validator running without any exposure to the internet. And then you can run Sentry nodes that are exposed to the internet and privately communicate with the validator. This is a setup that we've also followed, and it works pretty well. And there's a little bit of configuration to do on each of the nodes. So for instance, the Sentry nodes need to be aware of the validator needs to know about the Sentry nodes. The general pattern that we follow is we kind of distribute the Sentry nodes across different availability zones if we're deployed in the cloud, so that if one availability zone does go down, we're still up. The second thing that I wanted to talk about was seed nodes. So if you've been running your validators right now and using the scripts that are in the community repo, you might have noticed that we download a seeds file from a static seeds file from AWS, and this is the seed node that we are running in our infrastructure. And this is the node that then gives you the address book. So when you bring up a node or a validator, it comes up, it talks to the seed node, it pulls the latest address book, and then it discovers all the nodes that it needs to connect to. We don't want to be the only people who run the seed nodes. We want to encourage the community to also take part in that. For that, there's a simple configuration when you're running a node. I think it's called seed mode, and we would encourage people in the community to run a node in seed mode and then pass us the address and IP of that node so that we can add it to our static file. So when people actually try to connect to the validator, we're not the single point of failure for that. Yeah, I think that's pretty much it. I'll pass it on to Jackie or Gus, one of the two, to talk a little bit more.
So just one thing to clarify, right, Talal, I guess for the seed node, you can't run, a regular node in the seed mode. You have to run one node like in the seed mode and then a regular node on the side, right?
Yeah, so the seed mode is exclusive and it only operates as a seed node. So if you're running a regular node, this would be in addition to that node. You can't use them for two purposes. And the way seed nodes operate is they keep up with the latest blocks, but they don't actually do anything other than just returning an address book to other nodes that are trying to join the network.
Okay, if that's it from Talal, then I guess I'll take over.
Sounds good, Gus.
Excellent. Okay, so I'm going to talk to you a little bit about the monitoring of validators that we'd like to set up for the coming testnet and how it will evolve for mainnet. So we're working with ecosystem partners right now to develop or to improve existing dashboards and their monitoring of validators. So just to give you an idea of the kinds of things we would like to keep track of. So there are several metrics about validators that you might care about, some of which are generic to all Cosmos chains and others of which are specific to Axelar. So starting with the Cosmos generic chains, it's simple things that you might guess would be like percentage of uptime for the validator, number of times that validator has been jailed, the average response time of that validator when it is jailed, and so on. And the Axelar specific things, well, there's quite a lot of those, as you know. So I'm sure many of you are familiar that a lot of Axelar validators participate in multi-party cryptography protocols. Often there's a keygen protocol and a sign protocol. And so for each of these protocols, before the protocol begins, we kind of take a snapshot of which validators are online and ready and have required the necessary setup steps to participate in the keygen, and similarly for the sign. So we will keep track of that. So for example, of all the keygens that were there, what was the number or percentage that a given validator actually participated in the keygen versus not participated? And similarly for sign, of all the validators who happen to hold a share for a key for a given requested signature, which ones actually participated in the signature versus which ones didn't. Okay, so these are just kind of basic performance metrics. So for each one, the higher the number, the better you are doing at that metric. Other metrics would include external chain support. So as Sergey mentioned, we're starting with this opt-in feature for monitoring external chains. And so you validators will need to explicitly register for each external chain they would like to monitor. And so we will keep track of which ones you support and hopefully eventually the duration of that support. So, the begin and the end block of where your support began and ended. Other things, so other things include validator health. So simple things like, did you register a proxy? And the new testnet will roll out a new feature, which basically causes each validator to emit a heartbeat transaction every X number of blocks, where X is something like 50. So this heartbeat transaction will basically be, a self-declaration of, various health properties, like, so do I have a proxy? Can I connect to TOFN-D? Of the keys that are kind of like currently in rotation, do I have access to those in my TOFN-D? Is my status ready to go, or am I currently jailed, or something else like that? So this is another, thanks to these new heartbeat transactions, this is another source of data for metrics. So we can build a picture over time of which validators have healthy heartbeats and which ones have interruptions. Okay, another important metric would be the amount of rewards that validators earn from all functions. So this includes just basic Cosmos Tendermint consensus, but it also includes things like voting on external chain events or participating in multi-party crypto protocols. All of those things give rewards. And so, just adding up all the rewards that a validator has earned is a good measure of, how well that validator is performing his or her task. Okay. So as I mentioned, we would like to collect a lot of this data over time to kind of develop like a plot or a view of how well validators are doing over time, as opposed to just a snapshot by snapshot view of things. We would also like to construct a leaderboard. So this is going to be difficult, and this is still in the early phases of design. The leaderboard only comes after we've nailed down all the basic tracking of individual metrics and the collection of data over time. But once we've got those things, then we can design a leaderboard. And this is a challenging design problem because you've got a multi-dimensional space of validator metrics, and you somehow need to project that down into a one-dimensional metric, a single metric where we can order all the validators. And of course, that's always a challenge. We don't want to encourage validators to kind of game the metric. So some options for that are, well, we can not so much focus on a single ranked metric, but we can kind of have sort of a series of different ranked metrics or, queries. Like, for example, the vision is that eventually you'll be able to say things like, okay, show me, the validators with the most support for, say, Ethereum blockchain, or show me the validators who had the most consistent heartbeat, or show me the validators who have won the most rewards relative to their stake over time. So I think that could be a good way to do things. At this early stage, I would say if we had to pick one metric that would be, the leader, it would probably be rewards earned, because that kind of is a natural way to kind of aggregate all your performance across all these different metrics in one single easily measured number. But again, this is still very much in conceptualization phase. Yeah, so maybe I will I'll share my screen briefly if I have permission to do that, and I will kind of show you a prototype for what we have so far. Okay, can everyone see my browser? Can anyone not see my browser? Okay, I'm not hearing a no, so I'm going to continue as if you can. Okay, so this is just an example of, we're looking at one specific validator here. This is the Axelar Core 0 validator. And again, this is a prototype, so this is all subject to change, but this is just to give you a high-level overview of the vision that we have here. So here's some new validator metrics that we're looking at. So these are Cosmos generic metrics, such as the uptime, number of missed blocks, times jailed, average response time, and so on. Health check, here's the broadcaster registration. Currently, we have this number of blocks before a proxy was registered, because if you recall, you become a validator and then you register for a proxy. Now, of course, that is subject to change in the next testnet, but this is just one example of the many different kinds of metrics that we might have. Here we have Axelar specific stuff. So how many keygens did you participate in? How many did you miss? Similarly for sign, this particular validator participated in 615 signatures and missed 0 of them. So hooray. And this validator has earned this many rewards, 2.87 axles. And of that, I guess this is the commissions that they earned. Okay, and that's, I guess I will stop sharing here. And that's about all I have to say. If there are any follow-ups or questions, I can address those.
I have one question. Jonas from Chainode here. Is there any minimum of validators required to support the chain? So let's say, for example, we have a total validator set of 100, and maybe only 3 of them will want to support a specific chain. Is there a minimum requirement? And if so, will be good to have a governance channel, maybe where to discuss which channels most of us will agree to support and prioritize them.
So the short answer is yes, there will be a minimum number of validators required. That is a system parameter. I don't know the exact value off the top of my head. Perhaps Sergey might know better. But basically, my understanding is that validators declare which chains they want to support. And the first time a new chain is declared, nothing really happens because you need to cross this minimum number. But my understanding is then once the number of validators who have declared support for this chain crosses that minimum number, possibly stake weighted number of validators, then that chain will just kind of automatically be added to the Axelar network. And similarly, if enough validators drop support for an existing chain, then that chain will no longer be supported. Sergey, do you have any follow-ups to there? Just to clarify anything I may have said? Yeah,
so on the upcoming release, the threshold for supporting a new chain will be 40%. And then 33% of the validators will actually need to actively vote on it. We're gonna make sure that a few chains that we want to test on kind of are supported. And I think we'll kind of communicate what those chains are in the coming weeks. We definitely want to test things, I think, around Avalanche, I think around Polygon, maybe a couple others that we'll let you know. When the threshold, once the chain is activated, because that means that we deploy contracts on it and we can start, processing requests to that chain, the chain actually can never be deactivated, right? Because, you now have funds in those contracts, so we don't want to lose them. If the threshold of this 33% is not met for voting on a specific transfer, then you just have, a liveness problem, so that, funds cannot be moved in and out, but the contracts, of course, are not becoming deactivated, and they just continue living in those chains that we activated, and you can transfer within them. As soon as the threshold is met again of 33%, then you can start transferring things in and out. The parameters are not final for the mainnet. I think we'll have to wait and see how how the upcoming testnet will be maintained, and then we'll decide from there.
Awesome, thanks. And I will have another follow-up question related to the Sentry nodes architecture. While it comes with advantages, there is also a trade-off, and that is latency and speed, and also it requires that the Sentry nodes are also powerful enough to not hinder the overall network speed and health. Are there, or in the case we decide or we set as prerequisite that we should use Sentry network architecture, it will probably be good if we have a testnet where all validators will run such an architecture in order to measure the performance of the network prior to going to mainnet, to see if all the connections over RPC and Sentry nodes will work as expected overall in the network, not only a few nodes.
Yeah, I think we can definitely do a test of that. Try and prioritize that before the mainnet. As of now, at least all of our validators are behind Sentry nodes.
Cool.
I'm actually curious on that. Out of the folks that are here on the channel, if you're running other nodes for other chains, do you follow the Sentry setup? And maybe if you can talk, about your experience so far. I'm kind of curious on this.
I can say from my personal experience, I have both, but I can say, I think if a validator has some, usually we run also, besides the main validator node, also some full nodes in parallel. And I observed that usually the performance is much better without the Sentry architecture. And if you have the proper alerting system for your validator, you can pretty much quickly switch to a backup full node and be up and good. The trick is, as I said, I saw this on Kava in the past where there was a problem on the protocol level, and yeah, it required quite a lot of resources and IOPS, and many of the validators with the Sentry architecture were jailed. We then switched back to a dedicated full and powerful node, and that worked pretty well. So I think there is a trade-off. I know Polkadot, for example, they give up to using a Sentry architecture. They use it also at the beginning, but over time they gave up. I think if we don't have a high block time, it should work. But if we increase the block time, if we reduce the block time, then and the network will be pretty fast, then it could become pretty tricky, or it will require at least that we run pretty powerful Sentry nodes as well. So I guess
so.
Yeah.
Can you say what you mean by pretty powerful?
Like yeah, at least as powerful as the validator node. So I mean, if someone runs a full validator node on a bare metal machine, not to start to run any small Raspberry Pi VPSs as Sentry nodes, because that will hinder the performance of the validator overall. So the Sentry nodes have to be fast enough as well, like CPU, network, and latency. It's pretty important. Like for clear example, not to have a bare metal with 8 gigs of RAM or 16 gigs of RAM and CPU, dedicated CPU, 8 CPU, and then 60V CPU, and then have in front Sentry nodes that are 2 cores and 4 gigs of RAM, and a bad network. That will impact the performance of the validator in a negative way.
Yeah, okay. I think we can do some runs on how powerful we need those machines to be. In our case, all the machines are kind of equal. So the Sentry nodes are just as powerful as the validators themselves. But we'll try to determine how and what the impact is, and suggest appropriate sizing to the community. And to extend Sergey's question, I think if there's other aspects of other operational aspects with the nodes and with the validators that you think we're missing, or you would like to see in the future, please do let us know, and we'll try and fix it somewhere in our roadmap.
Okay, so maybe now is a good time for me to hand it off to Jackie.
Okay, hey guys, I'm going to talk a bit about monitoring the continued health and readiness of your validator node. So as you may have figured out from the presentation so far, running Axelar Validator extends beyond the typical setups of Cosmos chains. There's a bit more work to it. And so really there's 2 categories of checks that you need to watch out for in your day-to-day monitoring to make sure that your node is still running and configured correctly. One set of checks deals with the Tendermint consensus, right? So ensuring that your node is still continuing to participate in block creation and the Tendermint consensus underlying of Cosmos chains. And the other is the Axelar specific multi-party crypto protocols. So that is encompassed by a heartbeat that we've been adding, which will periodically scan the chain and ask validators to submit a check to see if they're ready to participate in a key generation or signing protocol. So we're working with partners to create dashboards so that validators can use these dashboards and quickly observe and check the statuses of the Tendermint consensus and the heartbeats. And as those are being built, you can use the logging and queries available from Axelar in the meantime to check these things yourselves. So we'll be releasing more instructions along with the new testnet detailing how you can do all of this. And please keep an eye out for the updates from the dashboards, which will have like a nice user interface and will be easy for you to use and monitor. Additionally, in the same vein, for voting, the logging will also be logging and queries that you can use, and the data will ultimately also be displayed on a dashboard. You can see the chains that you've registered. You can see your previous vote history and whether or not you've been able to participate and how you voted and so forth. Does anyone have any questions about this? Okay, great. I'll pass it back to Sergey to wrap things up.
Yeah, so I guess one question from Nathan on the chat: can testnet participants who completed exercise be granted enough tokens to run validators? Yes, so Nathan, on the plan for the upcoming release is that we'll delegate stake to some folks that are running validators, and we're going to make it more open. I think we'll communicate exactly what the process will be in the coming days, but you should be able to run a validator node on the next release. And then another question: how much voting is on chain? I guess can you clarify what you mean by that question?
Yeah, the previous speaker just talked about voting proposals and how your validator voted. So is all of that on chain?
Voting is on chain because we have to reach a consensus on every transaction. It's a sort of a finality feature that we need as we're moving funds from one chain to another. So the votes are propagated by the validators on chain, and then we reach an agreement on the majority vote. And so further, kind of in the mainnet and so on and so forth, then if your validator is not voting in accordance to the majority, then you get sort of penalized one way or another by losing rewards. How many more testnet phases are we planning, and when we're planning mainnet? How many testnet phases? So this testnet release that we have almost captures everything we are targeting for the initial rollout. So the integrations with some EVM chains, with this Cosmos chains, and some routing between them. We are doing audits in parallel. So first auditors started to work last week, and we have 2 more auditors that are scheduled over the next 2 months. And we have a few smaller changes that we want to add to the network itself. So there may be a couple of testnet phases, I would say, but in that there may be some hot patches or hot fixes that we try to deploy on the network. Then another thing we're going to be testing over the coming months is an ability to upgrade with all of you participating as validators, right? So either upgrades of various parameters through the governance module, or upgrade of the Axelar core itself. That has to be kind of coordinated following the Cosmos upgrade models. So those things we're going to be testing over the coming months as well. And then essentially, when everybody's comfortable that the network is robust and reliable enough for these initial integrations, we'll make it go live. And right now the target is early Q1 of next year, right? So we'll coordinate, I think, specific dates as we see how this network behaves. Right, another question: is the documentation to start validator going to be open to all testnet participants? The answer is yes. The plan is to make it more open to everybody on the upcoming release. The details, how that's going to be kind of communicated and how you get stake delegated, we'll announce in the coming days as we roll out the testnet. All right, any other questions?
Yeah, hi. First of all, thanks for the opportunity. So we started our validator node during the current testnet phase, and it kind of went down after a bit. So as Gus mentioned that, are we going to have that as a metric for the second phase as well, or is it going to be starting from scratch?
We're going to start from scratch measuring performance because we haven't really, we didn't have enough login or dashboards on the current testnet, so we kind of didn't keep an eye on the validator performance. So from the upcoming release, it'll be started fresh.
That's good to know. Thank you. And the other thing is, would you recommend any specific hardware specifications to start with?
So when you join as a validator, in the instructions, we're going to put recommendations. I believe there are some now. I think we need to revisit them perhaps after all the lessons we learned over the last few weeks. But yeah, we will put instructions there. One thing to think about, as you're thinking about validator setup, is that where you're going to run these other external nodes, right? So, if you want to vote on request to Avalanche or Polygon, again, you're going to have to set up that node, and you're going to have to query RPC endpoints if you want to earn rewards for it. So you should think a little bit: where is that going to be hosted, and how do you configure the right RPCs?
Sure. Thank you.
All right. What else is there? What's the predominant software language used in Axelar? Is it Go, or Rust, or both? Yeah, so the Axelar network itself is based on Go. That's just following the Cosmos APIs and SDK. The crypto libraries that we open source, they're based on Rust. So it's say mostly Go with Rust when it comes to cryptography. Do we need to host our own RPC nodes for external chains? We strongly suggest that you host your own nodes for external chains. This is not something, of course, we can kind of confirm or verify easily, but for the purpose of decentralizing the network and making it more robust, we don't want to have to rely on external providers for those things. And most of them, pretty straightforward to run just a regular node, like for Avalanche or for Ethereum. It's kind of pretty well documented by now, and you can spin it up very easily. So if you're running an Axelar validator, you want to connect and have both Axelar and Axelar. No, so again, you only run the Axelar validator. For other chains, you run a non-validated nodes, right? Just a regular nodes in order to be able to read transactions from that chain. And again, you get to choose which ones you want, and then the rewards are structured appropriately to kind of incentivize you to choose as many as possible. But you get to decide which ones you want to vote on. But those are non-validated nodes again, and so the complexity of running them is sort of a lot lower. And if one goes down, you just spin up another one and change your RPC endpoint.
Yeah, really the purpose of these is just that you observe events on these external chains for yourself so that you can vote on them. You don't have to participate in validation of those chains.
Awesome, great questions. Anything else? ETH nodes, full node or light node? Same question for other chains. So it really depends on the definition of full versus light in each one of these chains. And I think some of them kind of define it differently. Yeah, actually, if you clarify what is in your definition of full versus light, we'll say whether or not that's enough. Like, you don't have to have an archival node, right? Like, we don't need historical data for that's been processed forever. We only need sort of the active state of those chains in order to be able to query like the latest state of the requests that are coming in our gateway contracts and then vote on that. So yeah, I think and node with sufficiently long history, but like not an archival node is sufficient. And again, it's not a validated node.
Yeah, like I would say, ultimately, you as a validator are responsible for accurately reporting events on external chains. So to the extent that a light node is insufficient to get accurate reporting information, then no, you shouldn't do that.
All right, somebody said you can't connect to light nodes on Ethereum. Yeah, I think it depends on the implementation, but yeah. All right, anything else?
Maybe another question from my side. Do you guys also plan to release like a guide how the validators can set up their nodes and their validators in a manual way instead of using scripts, just to provide more in-depth knowledge about what is happening in those scripts? Because with the scripts, yeah, it might look pretty easy. You run them, but it depends if the validators look into them or not. But it could look like some sort of voodoo. And it will become trickier when you try to debug. You will have at least then to start to look into those scripts to see what is happening.
Yeah. Right now we are planning to follow, the binary release and the Docker release, primarily because, it's not trivial to set up validators, and there's a kind of learning curve there. And we're trying to make it as simple as possible to do that by, automating things in the Docker or the binary release. If you follow the binary setup and you look at the scripts, you can get an understanding of what's going on sort of under the hood. So I think the answer is, in the short term, probably not, just because we don't have enough resources to support 3 modes of deployment. We can only support 2 right now. In the long term, it is a good idea, but we have to figure out how do we find enough time to manage kind of all 3 releases then.
Got it. Thanks. Maybe another one. Sorry. Have you seen any performance discrepancies between running the node or the validator connected to other RPC chains in the Docker mode versus pure binary mode on your side?
So we mostly actually run in the Docker mode, and we haven't really had any performance issues. I think as you saw on the dashboard that like Gus showed, our validators like had 100% sort of participation rate in various events. Assuming you have enough resources and everything is set up correctly, I think either mode should be fine.
Oh, cool. Thanks.
Hi, I have also a question. Do we have any cap for the amount of validators, or everybody simply participate?
There is a cap, right? Same as following kind of a Cosmos model. I think on this testnet, so anybody can run a validator, right? Anybody can register, but the ones that are going to be responsible for the block production is only the ones that have kind of top stake delegated to them. I think on this release, we'll set it to something like 50, and then kind of extend or shrink it. Well, hopefully extend from there. But anybody can set up a node, just like in Cosmos you have. Anybody can run a validator, but then the top ones are selected for the block production itself.
Okay, thank you.
How are people going to be in active validator set on mainnet? Are there some sort of validator sale validators on the testnet? Well, one of the things that we're going to do on this upcoming testnet, as I mentioned, is that we'll measure sort of performance, right, of the validators. And the foundation is thinking through a delegation program where the validators that ended up on top of the leadership board will be delegated a certain stake to help them bootstrap in the early days of the mainnet, and then we'll go from there.